Hello, grade 7. Our math lesson today is about algebraic expressions. Chapter 15, Algebraic Expressions. Definition. An algebraic expression is a collection of letters called variables and numbers, organized in some manner using the operations addition, subtraction, multiplication, or division. 4 times x to the power of 2 plus 3 times x times y is an algebraic expression. 4 times x squared and 3 times x times y are the terms of this expression. Each term in an algebraic expression is called a monomial. Therefore, 4 times x to the power of 2 and 3 times x times y are monomials. In the monomial 4 times x to the power of 2, 4 is called the coefficient and x the variable. In the monomial 3 times x times y, 3 is the coefficient, x and y are the variables. Simplified writing. The literal writing a times b is ab. A and b are the factors of the product ab. A being an integer and n a natural number, we write a plus a plus a plus a n times or n terms is equal to n times a or na. A plus a is equal to 2a. A plus a plus a equals 3a. Z plus z plus z plus z equals 4z. But pay attention. 5 plus 5 plus 5 is written as 3 times 5, which is equal to 15, and not 35. Complete the following table. The first monomial is negative 5x to the power of 3. The variable here is x. The coefficient is negative 5. The exponent of the variable is 3, since it's negative 5x to the power of 3. Now, if the variable is y, the coefficient is negative 1.5, and the exponent of the variable is 2, the monomial would be negative 1.5 y to the power of 2. The third monomial is x to the power of 8. The variable in this monomial is x. The coefficient is obviously 1, and the exponent of the variable is 8. Now, if the variable is a, the coefficient is 2, and the exponent of the variable is 5, the monomial is 2a to the power of 5. 3y to the power of 2. The variable here is y. The coefficient is 3, and the exponent of the variable is 2. If the variable is t, the coefficient is negative 3.5, and the exponent is 1. The monomial is negative 3.5t. Like terms. We call like terms the terms that differ only by their coefficients. Examples. 7x to the power of 6 and negative 3x to the power of 6 are two like terms, since in both terms the variable is x and the exponent of the variable is 6. Negative 3x to the power of 6, y, and 5x to the power of 6, y, to the power of 2 are not like terms. Both terms have x and y as variables, but the exponent of the variable y is 1 in the first term, but 2 in the second term. 6a to the power of 3b to the power of 2 and negative 5a to the power of 3b to the power of 2 are two like terms. 8x to the power of 3 and negative 3x to the power of 2 are not like terms. The variable x is the same in both terms, but the exponent of the variable is 3 in the first term and 2 in the second term. Negative 3x to the power of 2, z to the power of 3, 24x to the power of 2, z to the power of 3, and negative 8x to the power of 2, z to the power of 3 are like terms. Circle the like terms. 3x to the power of 5 and negative 4x to the power of 5 are like terms. Negative 2a to the power of 2b to the power of 3, 3 over 4a to the power of 2b to the power of 3, and negative 0.5a to the power of 2b to the power of 3 are like terms. 6x to the power of 5 y to the power of 2, and negative 1 over 5x to the power of 5 y to the power of 2 are like terms. Finally, negative 1.5t to the power of 3 and 4 over 5t to the power of 3 are like terms. Numerical value. The numerical value of an algebraic expression is the result obtained by replacing the letters by given numbers and performing the given operations. Examples. 1. Calculate the numerical value of the algebraic expression 6a to the power of 2c minus 8b to the power of 3c to the power of 2, for 8 equals negative 1, b equals 2, and c equals 1.5. The numerical value of the algebraic expression 6a to the power of 2c minus 8b to the power of 3c to the power of 2, for a equals negative 1, b equals 2, and c equals 1.5 is 6 times negative 1 to the power of 2 times 1.5 minus 8 times 2 to the power of 3 times 1.5 to the power of 2. So I substituted negative 1 for a, 2 for b, and 1.5 for c. I start by finding the value of the exponents. The answer is 6 times 1 times 1.5 minus 8 times 8 times 2.25. 6 times 1 times 1.5 is equal to 9. 8 times 8 times 2.25 is equal to 144. So I have to subtract 144 from 9. The answer is negative 135. Calculate the numerical value of the algebraic expression 3x to the power of 2y plus 5x to the power of 3, for x equals 2 and y equals 3. The numerical value of the algebraic expression 3x to the power of 2y plus 5x to the power of 3 for x equals 2 and y equals 3 is 3 times 2 to the power of 2 times 3 plus 5 times 2 to the power of 3, which is equal to 3 times 4 times 3 plus 5 times 8. 3 times 4 times 3 is equal to 36. 5 times 8 is equal to 40. So now I have to add 36 and 40. The answer is 76. Multiplication of monomials. The product of two or more monomials is obtained by multiplying their coefficients and adding the exponents of the same variable. Examples. I start by multiplying the coefficients. 7 times negative 3 is equal to negative 21. Now I add the exponents of the same variable x. 6 plus 2 equals 8. Y appears only in the second term, so the answer is negative 21 x to the power of 8y. In the second expression, I start by multiplying the coefficients. Negative 3 times 5 times 2 is equal to negative 30. Now I add the exponents of the same variable x. 6 plus 3 plus 1 equals 10. Next, I add the exponents of the same variable y. 1 and 2 equals 3. So the answer is negative 30 x to the power of 10 y to the power of 3. In the third example, I multiply 6 by negative 5. The answer is negative 30. I add the exponents of the variable a. 3 plus 2 plus 3 is equal to 8. b only appears in the first term. So the answer is negative 30 a to the power of 8 b to the power of 2. In the fourth example, I multiply negative 4 by 2. The answer is negative 8. I add the exponents of the variable x. 3 plus 4 plus 1 is equal to 8. So the answer is negative 8x to the power of 8. 3ab to the power of 2 times negative 2a to the power of 2b times 5c is equal to negative 30 a to the power of 3 b to the power of 3 c. Calculation of algebraic expressions. Reducing like terms. To reduce like terms in an algebraic expression is to replace them by a unique term. Simplify by adding or subtracting their coefficients. So, to add or subtract like terms, I simply have to add or subtract the coefficients. Reduce the like terms in each of the following algebraic expressions. 3x to the power of 2 plus 4y to the power of 2 minus 5x to the power of 2 plus y to the power of 2 plus x to the power of 2 minus 5 minus 2y to the power of 2 is equal to negative x to the power of 2 plus 3y to the power of 2 minus 5. Since 3 minus 5 plus 1 is equal to negative 1 and 4 plus 1 minus 2 is equal to 3. In the second expression, the like terms are negative 4a to the power of 2b and 2a to the power of 2b. Their sum is negative 2a to the power of 2b. 3xy to the power of 2 and negative xy to the power of 2 are also like terms. Their sum is 2xy to the power of 2, and 8 minus 4 is equal to 4. So, the answer is negative 2a to the power of 2b plus 2xy to the power of 2 plus 4. 3m minus 4bm plus 3b minus 5m plus 6bm plus 7b minus 5 is equal to negative 2m plus 2bm plus 10b minus 5. Addition of algebraic expressions. To add algebraic expressions, we write them in succession by preserving the signs of their terms, and we reduce the like terms. Let's calculate a plus b. A plus b equals 3x to the power of 2 minus 4x plus 5 minus 5x to the power of 2 plus 3x minus 7. The answer is negative 2x to the power of 2 minus x minus 2. Subtraction of algebraic expressions. To subtract an algebraic expression from another, we write them in succession by changing the signs of the terms of the expression to be subtracted, and we reduce the like terms. Let's calculate a minus b. A minus b equals 2x to the power of 3 minus 4x plus 5 minus in parentheses 2x minus 7 plus 5x to the power of 3. Now we use the distributive property. A minus b equals 2x to the power of 3 minus 4x plus 5 minus 2x plus 7 minus 5x to the power of 3. A minus b equals negative 3x to the power of 3 minus 6x plus 12. Now let's calculate p minus q. P minus q equals 3a to the power of 2 minus 4ab plus 5b minus in parentheses 2ab plus a to the power of 2 minus 5b plus 8. Now I use the distributive property. P minus q equals 3a to the power of 2 minus 4ab plus 5b minus 2ab minus a to the power of 2 plus 5b minus 8. P minus q equals 2a to the power of 2 minus 6ab plus 10b minus 8. Now let's calculate c minus d. C minus d equals 3xy to the power of 3 plus 5x to the power of 2 minus 8y plus 7 minus in parentheses 2x to the power of 2 minus xy to the power of 3 plus 2y minus 8. C minus d equals 3xy to the power of 3 plus 5x to the power of 2 minus 8y plus 7 minus 2x to the power of 2 plus xy to the power of 3 minus 2y plus 8. C minus d equals 4xy to the power of 3 plus 3x to the power of 2 minus 10y plus 15. That's it for now. Thank you for watching.